All right, so I wanted to talk about equality because I'm doing some work to enhance equality in ScalaTest and Scalactic, and I just thought I would sort of show you my work in progress, and maybe if anybody's here tonight, we could talk about it if you want to. And I wanted to start by kind of describing what equality is from the set perspective. In mathematics, basically, there's this notion of an equivalence class. A set has a bunch of members, and if you take all those members and put them in groups, like we could take the people in this room and put them in groups by their birth month. So all the people with January birthdays would be over here, and you put a little circle around them. All the people with February birthdays would be over here, and you put a little circle around them. And then you can make a relation between people who have the same birth month as, right? So that's an equivalence relation. And what equality is it's when you have an equivalence relation where every equivalence class has just one element in it. So for example, for the set of integers, there's an equivalence class that just has 41 in it. There's an equivalence class that just has 42 in it. There's an equivalence class that just has 43 in it. And the relation is 41 is equal to 41. 42 is equal to 42, right? And then that relation is reflective, symmetric, and transitive. So that's what it is from math. And so one of the challenges when you bring that to programming is there's actually lots of different ways to say 42 in code, right? You can just say 42, but you can also say 42L, and that's actually a different type. You can say 2 short, 2 byte, get even smaller ones. There's a big int 42, there's a big decimal 42. The character asterisk character actually has Unicode value 42, so that's another way to say 42. There's all these Java wrapper types, java.lang.Byte, double, integer, long, character, float, short. You can say 42 in those guys. Java has a big integer and a big decimal. Those guys can say 42. And you can make your own types. Like I made a complex number type and a digit string type. And those guys can say 42, right? So one of the things that you have to decide is like who can actually be equal to whom. And what Java did is they just make this equals method in java.lang.Object that takes another object. And then you can see there they have reflexive, symmetric, and transitive. That's part of the laws you're supposed to obey when you implement equals. But they have 2 extra ones that weren't sort of in the mathematics, one of which is consistent because objects can mutate in Java on the JVM. So what consistent says is like between mutations, it should act like an immutable object. So the equals should always return the same thing given the same input. And then there's another thing that's kind of not in the math is null. You can't, something can be null on the Java platform. So they just say only null can equal null. No non-null object can say that it equals null. And that's Java's equals. Scala has this double equals method that takes an any that kind of fixes an inconsistency in Java's double equals and pretty much does the same thing. And it's called universal equality by a lot of people because anything can be paired with anything, right? So one thing that allows is all these things could be compared with each other. You can actually pass anything to any other equals method. So they could actually say they're equal to each other if you wanted. So it turns out that Scala fixed some inconsistencies in Java in this area, and all these types that are dark purple up there, Scala makes them cooperatively allow them to equal each other. So you can actually say 42 equals 42L with double equals, and it's true. You can say a big decimal 42 equals asterisk, and it is true, right? Because they both are the value 42. So there's a lot of different ways to say it. And it even magically makes the wrapper types know about the other ones. It never calls the actual equals method on java.lang float. It just sort of magically fixes it. So a java.lang float says it can be equal to a short. So it now will actually work nested. So you can have these deeply nested things, containers, and deep down inside there could be a 4 long and a 4.0 double, and those things can still equal each other. And you don't actually have to convert anything, so it's actually an efficient way to compare things like that. If you really just are trying to say, if all you care about is it's the concept 42, this allows you to efficiently determine that. Okay. So what people have asked me for in ScalaTest over the years, there's basically 2 things they wanted. One is they wanted an alternate way to Well, a way to specify an alternate equality than the built-in one. So some examples are arrays by default. Their double equals method just says, does identity comparison? Are these the two exact same instances? And what you usually want is a structural comparison. Does it contain the same elements? So that's one example of an alternate equality. Another one is XML. XML, actually, it makes sense that it does this. It cares about white space. If there's a little white space difference in the two XML, node seeks, it'll be false, right? But in tests, a lot of times people don't care about white space, and they'd like another equality that actually ignores white space. The default equality for big decimal, Java's big decimal, actually cares about scale. So I think that's backwards. They have another method that doesn't care about scale. I think it should be that, by default, 42 means 42 means 42. Since that's the case, the alternate equality is one that actually doesn't care about scale. Sometimes you actually don't care about, you kind of want a fuzzy equality for real numbers or for doubles. And maybe you want a case-insensitive comparison for strings for equality, right? These are all different alternate equalities you might want. And the other thing people wanted was type errors because I can compare anything with anything, then I can say 42 the string equals 42 the integer, and that will always be false. It's almost certainly a bug. But even if it isn't a bug, if you meant to say that, it's better to replace that with false. It's clearer when you're reading the code, right? And it can sometimes not be very obvious because this deeply nested structure is false because there's a long and a string deep down in the same spot, right? So it makes sense that people would like that to just not compile. But the question then for me was, how do I decide what should and should not compile? So what my intuition is like, well, if it can equal, if it can be equal, then maybe it should compile. But if it can't ever equal, like a string can never equal an int, then maybe it should not compile. So you can get a type error in ScalaTest since 2.0 or Scalactic for things like strings compared with ints, right? But BigInt and big decimal, they actually can equal each other because Scala does that magic and cooperative. Well, actually, this isn't magic. It's just the equals method of BigInt knows about big decimal, and the equals method of big decimal knows about BigInt. Right, so that is allowed to compile, and you actually let it be true or false. So that's one thing. But then there's also things that could always be false, right? So two empty seeks, two seek of nothing, right? If you see a list of nothing and a vector of nothing, you know those have to be empty. That means they'll always be true. They'll always be equal. So maybe that should actually not compile, and a better way to write that is true, right? Because that's always going to be true. But the only way to really do that with implicits is to make ambiguous implicits, like to turn them off, because it's not the only way, but it's what you normally want to do with lists or for seeks is say any two seeks can be compared if the inner types are sensible to compare. So once you do that, the only way to turn off empty ones is with ambiguous implicits, and I really don't like that. So I actually implemented it just so I could get this error message that's kind of ugly, and then I took it out because I don't think probably that's what I'm going to do. But if you have like a vector of nothing and a list of int, that actually should definitely compile because the list of int could be empty, which means the answer would be true, or it could be non-empty, which means the answer would be false. So if it's interesting, if it could be true or false, then I think it should compile. So that was my first candidate rule, just like seat of the pants rule, is if it's an interesting comparison, it should, maybe it should be allowed to compile. And definitely if it's a boring comparison, it's always going to be true or always going to be false. It probably shouldn't be allowed to compile. OK, so that's one rule, or one idea. But what about implicit conversions? Because another thing all those different types, a lot of them have implicit conversions between them. Like there's an implicit conversion between int and long. Right, so that's maybe how you could think about why those guys should be allowed to compile. So I made this complex type, a simple type for complex numbers on top there, and I made an implicit conversion from int to complex. Right? So should I now allow ints to be compared with complex numbers? So my intuition here was, well, sometimes it makes sense, but sometimes it doesn't make sense, and I wasn't sure when it would and when it wouldn't. in ScalaTest 2.0, I actually made this thing called conversion checked triple equals because people actually asked for that. They said, sometimes I actually want to be able to compare things and have it magically implicitly convert one to the other and then compare. But I, over time, decided I think that's kind of too blunt an instrument because it turns on all implicit conversions. And sometimes it's going to make sense, sometimes it doesn't make sense. So what I'm moving to is that you actually have to enable implicit conversions. So the new stuff, in 3.0, I think conversion check triple equals will be deprecated. And you'll actually have to enable specific implicit conversions. So I can just say enable equality between int and complex. And that picks up this implicit conversion from int to complex, and now I can compare them. But definitely there's implicit conversions that don't make sense. Like there's this implicit conversion that adds should to everything and matchers. So a should wrapper of int, I don't think that should be compared to int. And there's actually a lot of things that it just doesn't really make sense to compare. But it's like I was having a hard time figuring out what kind of rule I would use to decide. And this Paul Snively actually tweeted a link to a paper a few weeks ago that gave me something that was sort of more formal. It's John Reynolds using category theory to design implicit conversions and generic operators. And what he said is it's OK to do it if it's an injection. And what an injection is a implicit conversion that doesn't lose information. So when you convert from int to long, all of the possible values of int fit in a long, so you can't lose anything. So it would make sense to allow equality comparisons between integer and reals, because integers fit inside reals, between reals and complex numbers, because reals fit inside there. But there's this thing called digit string, which it doesn't make sense. It's OK to have an implicit conversion, but you don't want to actually let them be compared for equality, because you lose information. So what you can lose is you lose how many zeros are in front. Right? So all the digit string is a string of digits, and it's enforced that it's a valid int. And the implicit conversion just converts it to int. And when I compare 42 with 042, that's false. But if I convert them to int, it's true. So that gave me confidence that if something is an injection, if something's a widening conversion, it actually should be OK to allow them to compare. But so it's like not a very simple rules, but here's the if it's interesting, it may be able to compile, and if it's in some implicits, should be allowed to compile, and definitely things that aren't injections, you probably shouldn't be allowed to compile. So then there's the question of subtype supertype, and subtype supertype is you can think of it as an implicit conversion, because whenever a supertype is asked for, you can pass in a subtype, and what you can think of that as is it's converting the subtype to the supertype and passing it in, right? And there's actually this symbol less than colon less than that you can use that is a implicit evidence that the left side is a subtype of the supertype. It's also an implicit conversion from the left side to the, from the left side to the right side. So from the subtype to the supertype. So essentially, it actually passes both of those previous rules. It is interesting. Something can equal or not be equal to a supertype or a subtype. And it's actually a injection, right? You don't lose information. It's actually the same object, so I didn't lose anything. Here I have an option of int being compared with a sum of int, which is a subtype. I have, well, in both directions. And then I have sum of int compared with itself. And this subtype-supertype relationship is reflexive. So that actually is also, you could think of it as being converted by this funny little operator. But is it always desirable? So I want to give two examples where, I think there's a lot of times where it isn't always desirable. So one example is this method EQV, which takes two t's and then calls triple equals, which is like, say, ScalaTest or Scalactic's triple equals. And there's actually almost certainly a bug in that line of code because I forgot, because triple equals takes an equality of t, and I forgot to pass it in. So it should actually be, there should be an implicit equality of t being asked for by EQV in the first place. But it compiles because Scala will infer any, and any is a supertype of everything, so it'll let anything compare with anything, right? So that actually will allow one to be compared with a unit. And that's a problem. And then here's two functions that will, they're both extensionally equal, because if you pass in the same int, you'll get the same output. And they're intentionally equal because they're actually implemented in the exact same way. But Scala, in programming, it's not really practical to actually do that comparison, because to implement an equals method to check that, I would need to go from minint to maxint and make sure both of these functions return the same thing. So we just don't do it. We just make you use the default equality that Java gives you that says these two are the same instance. And we never call double equals on that. So if we do call double equals, maybe it shouldn't compile, because it's possibly a bug. I mean, it's probably a bug. But even if it isn't a bug, a better way to say that is with the EQ operator, because it's more obvious to the reader of the code that this is being compared for identity equality. Actually, let me take questions at the end, but don't forget that one, because I'm not sure. It'll take me a while to think about it. But anyway, sort of where I was heading, right now there's these three equality policies that you can use. There's triple equals, which doesn't check anything. There's type check triple equals, which does subtype supertype. And there's conversion check triple equals, which enables all implicit conversions. And so those will continue to work, but they'll be deprecated. And these would be the new ones that I think will come, which is unchecked equality, checked equality, and enabled equality. And so what enabled equality is that you have to enable things. And basically the way to fix these is to force you to actually say, I meant to do that, right? So the benefit is now these guys don't compile if you use enabled equality. So you get a type error, which is a good thing. The bad thing is if you create a case class person, you can't compare two persons for equality until you actually say you mean to do that, right? So it's more kind of boilerplate code, but it's just one line. You say, I want to enable equality for person, and now I can compare two persons. So I think it's like a dial you turn. The unchecked equality is the fastest to compile, because these guys are going to be doing implicit searches to prove that it's OK to actually say this equals that, which is slightly slower, but worth it for a lot of people. The enabled equality is actually the best error checker, but it has a little bit extra. It's like the highest maintenance one, right? It asks you to write all that stuff. So one change I'm going to make to ScalaTest is equal and B will become also checking. They'll check for sensible equality comparisons. Right now, only this should triple equals does. So that's one change. Before, B actually didn't. It was basically called double equals, so now I need one of those, so I'm going to add B underscore double equals. So that means I just call double equals. I don't do a type check. I don't do any kind of customizable equality or anything. So that'll be the fastest compile one, but it'll allow you to compare very quickly, compile a comparison from a string to an int, right? And then the contain matchers will also be, or they're already doing this in master. They give you a type error for suspicious equality comparisons. Well, not actually equality, but containership comparison. It's all of them, not just should contain, but should contain one of, none of, all of, the same elements as, all those things. And then I want to add this operator. Actually, this is also in master. It's a type-safe containership check for production code. Since everything has contain on it already, you can't just like make a new contain. So I switched it around. So instead of saying, does this list contain this element, you say, is this element in that list? So one is in list 1, 2, 3 works, but a string is in list 1, 2, 3 doesn't. It gives you the compiler error. OK. So I'm going to actually go to this extra bonus slide and just briefly kind of talk about how it's different from what's out there already. Like Scala Z and Spire and Haskell have a type class that is takes one type parameter. And that's how they do two things with that. One is they allow you to decide to say what equality means for that type. And they use the presence or absence of that. Well, they use the presence of it to enable the comparison, right? So when you bring that into Scala, it has this issue with implicit conversions. In one, when the implicit conversion goes from right to left, it actually enables the comparison. When it goes from left to right, it doesn't compile. So what I did is actually made two constraints. There's two reasons for that. One is that you can either make this both compile or both not compile, which I think it's nice that it's symmetric, because equality is supposed to be symmetric. But the other thing that allows when you have two types is you can do, you can allow a big decimal and a big int to be compared directly, right? Whereas when you just have one type parameter, you can't say that, because the only type that those two guys, well, actually, I'm not sure what their supertypes are. Let's say, let me go to primitive types. Double and int, you can allow those to be compared directly. And the only supertype also is a supertype of unit, which you don't want to enable, right? So I think that's useful on the Java platform, because it's going to be, it's not that time consuming to convert a int to a long. But if you have a list of int, to compare that with a list of long, you'd actually have to convert the list of int. If you didn't actually have this cooperative equality going on, you'd have to convert the list of int to the list of long, and that can take a long time, right? And it would take twice as much memory. So anyway, that is my talk. So I think, do we have, how much time do I have for questions? Any? OK. Anybody have a question? Why don't we go with you, because did you remember?
I was saying, you could do macro, you get the passing tree of the instructions, see whether maybe just need the variable.
You mean, which one was it? Which was the context? Was it the function one? Yeah. Yeah, I think that's trying a bit hard, but yeah, it may be possible. It might be a good project for you. Anybody else? 60 seconds? Going once? Going twice? All right, thank you very much.